This is a calculator made using Arduino Uno and some other basic components. I've coded my calculator to do basic mathematical operations like addition, subtraction, multiplication, division, and also find square roots of a number and log base 10 of a number. I don't have enough switches to make this work, so I had to use a remote and an IR receiver, which I'm going to explain to you later in the video. I've opened my circuit in Tinkercad. Let's go through all the wires and understand how this makes sense. After plugging in 5V and ground to these two lines over here, plus line is 5V and minus line is ground. Now we connect the digital LED's first pin to the ground, the second pin to 5V, and the third pin to the resistance. Now, instead of using the single resistor, I'm going to use a potentiometer as a rheostat. The fourth pin, which is the resistor select, goes to the 12th pin of the Arduino, D12. The fifth pin, which is read and write, goes to the ground. The sixth pin, E, is enable, which goes to the 11th pin on the Arduino, D11. For now, we are not going to use D0, D1, D2, then D3. D4, D5, D6 are data bits which carry information from Arduino to the screen and use them to write text. The last two pins are the backlight of the LED. You will connect the anode with a resistor and the cathode with a normal wire to the ground. An LCD stands for liquid crystal display. They work by sending electrical charges to a grid of rows and columns. When the current passes through, the crystals align and the light below it would not deflect, and the polarizer above the crystals would actually prevent the light from getting out. When the current doesn't pass through the grid, the crystals misalign, causing the incident light to escape. Now, why did I use a potentiometer? This is a potentiometer made using a galvanometer. When you use a wire to only have the specific part of the resistance, it's the same as turning the wiper around. Here the pins on the side are plus and minus, and the resistance lets some current through the middle pin. And the middle pin is connected to the third pin of our display, which is contrast. This is the infrared ray sensor. When infrared rays pass through, it acts as a transistor. The receiver module outputs a digital code. The right pin is plus and the middle one is minus. The left one would carry the digital input. Now go to the Arduino IDE app and set your inputs to digital pin number on your Arduino. Here I've added all the digital pins that I've connected to the LED. I've listed all the commands from my remote and added a function to it. Then I've added all of the other codes to handle the operation. What's the buzzer for?